Hello guys! I'm glad that you are find time for being to be here to listen our speeches and to be part of this PHP Beer community. This is really great that we are together, and thank you Sam for making it happen for our speech. Really appreciate that. And today we are talking about the Symfony Messenger. Probably we are working with our previous speaker. We are working in the same field. We're working in the payment processing, and also I'm also working in payment processing. But as you said before, you probably will look into switching your current solution to the Symfony Messenger. And probably I hope you will like this speech. And let's continue, guys. Make some noise. First of all, who I am? I'm Alexander. I'm a backend developer in Mayflower, and I'm working in a payment processing department. And we are here for discussing Symfony Messenger. We will try to integrate it in our Symfony project because we are working on our project doesn't have any specific framework. For me, we use some parts of the Symfony, some parts of Laravel, and sometimes we are tuning it. And we'll look under the hood of the component, and probably will draw some conclusion about this package. Should we use it or not? And a little disclaimer. If you have project without DI container, probably it's not the best idea to use this component, and probably you need to start from to add for your project DI container first of all. Okay. What is the problem to solve? For now, we have a little bit crude implementation of the queues and with Redis list inside of it, and because we are moved to the cloud platform, via cloud platform, we move to the Kubernetes, and we sometimes have inefficient guarantees for our payment system is quite necessary, and we need to integrate it to the custom project without the framework. When we are trying to integrate Laravel, it's was the best idea because you need to do a lot of changes to your project, and also we need to avoid making significant changes to infrastructure. Preferably keep Redis as the message broker because we already have big infrastructure with Redis. And also we need to have out-of-the-box mechanism for retry and reject messages, because the current implementation is quite crude, and I don't like it. And provide some ability to extend the component. The current queue with integration with only work with Redis. We need to somehow switch it. We need to have an idea how to switch it to the other brokers. And why Symfony Messenger? Because it supports modern Redis streams from the extension. Link to the extension it's here, and support retry and reject avoiding retry feature. Support variety of message brokers, for example, MQP, Redis, Kafka, SQS from the box. It's already in the box. Almost all the parts of the company can be customized. You can customize serializer, you can customize message broker, you can customize anything you want. And also, because I like Symfony, probably from the previous speech I gave on the PHP Beer community, you already know that. Okay, let's continue. We'll do it according to the presentation plan. First of all, we inspect how it works in Symfony, and then we will look at what's under the hood. Then I'll show you some interesting feature of this component. Then explain how to integrate in your project. We won't do something really difficult to understand. We just do some basic stuff to how to integrate in your project. And discuss pros and cons of the packages. We can discuss it after the presentation also. And what is not our plan? We want to overview all the components, or all the classes of this component, because it's too many classes to discuss here. For analysis integration with all the brokers, because they are different. We also want to do examination of the age-specific class of the library. Also, we want to do performance measurement, because your configuration can be different with different message brokers. It can show different performance. And also, we want to do some very complex cases just to show the basic of this component. And if you wanna give a talk and you can contact with our organizers, is here, PHP Beer community, who haven't subscribed yet, you should try. What is the messenger, first of all? Messenger is a package for asynchronous message processing. It includes various drivers for implementing message processing using different message brokers, RabbitMQ, Redis, Kafka, and other message brokers. Top level architecture is here on the left side. You can see in the middle bus, in the right sender, messages, receiver, and the handler and the application. As you can see in the main page of this component, you will see that this component was inspired by the block of one of the developer. It's a command bus. Probably you're familiar with this concept as CQRS. Probably you're familiar with this concept. It's pretty similar, I would say. Let's check how it works in Symfony. As you can see, there is a class. We just create a class like test message, and just a simple value, integer value. That's it. This is the message on our diagram. Then you create the handler, for example, test message handler for our message, and with one magic method invoke that accepts our message. As you can see, we just do simple stuff. We just log this value from this message into the logger. That's it. This is our handler on our diagram. This accepts the message and handle it. To make it work in Symfony, you need to configure Symfony Messenger. First of all, you need to configure transport. Then you need to configure a retry strategy if you need a retry strategy, and you need to configure some routing for your messages. For example, it's going to be in the queue test message. For example, you might not do this configuration, but I just like the idea that one handler can process only one type of message. That's probably it. But the complex transport configuration you can find also on this link. How to use it? As an example, you can use it in controller, just to add message bus interface into your constructor, and then just create a message and dispatch it. That's it. As you can see, this interaction in the diagram here. Message bus sends the application to the message bus, and that's it. What's next? Somehow we need to process our messages, and we do it by executing the CLI command that handles the messages. It's just a simple worker. As you probably know, you use supervisor D, and you use Kubernetes container to run it. And then something happened. And then profit. And that's it, guys. Thank you for attention. Nope. Just a joke. We need to dig into a little bit deeper, guys. And we start with our main part in the middle, our message bus. How it's look inside? Well, Does this interface familiar for you? Yes? What is this? something, yep. Event dispatcher, maybe. Something similar. Okay. It's similar to event dispatcher. It also accepts our message. Message can be anything, and also accepts arrays of stamp. It's something really strange. As you can see, stamp interfaces. Just simple interface, and only one method. And it returns envelope. And what is the beast this envelope? What it does? How it looks inside? And envelope is just a class that consists our message and array of stamps and list of stamp interface object. What is the stamp interface object? Well, as you can see, this consists nothing, but only one thing: stamps must be serializable value object for a transport. Okay, you need to remember that. And what's inside the message bus implementation? Well, as you can see, it's strange things here. You have a terrible array of middlewares, and by default it's also empty. And I don't see anything that's working with the message broker here. How does it happen? I don't believe in magic, honestly. Because, for example, in Laravel, you can see the Redis queue and the configuration that passes via constructor. And let's find out how it's configured in Symfony. And we run our xdebug and see somehow it configured like that. Looks a little bit scary, isn't it? And some parts of this configuration are mandatory, some not. And we need to find out what we need to configure our our message bus. And first of all, we see our traceable middleware. This is first middleware only. And only one purpose of this middleware is to trace the execution of other middleware. It has stopwatch inside to track the memory and the time each middleware to process take. And also it has a traceable stack. And what is this traceable stack? Traceable stack it's a helper class that helps for stack tracing. And as you understand, the middleware can skip it in configuration. This middleware mostly for debug purposes. And probably we need to continue. And as we can see, there is another middleware, add bus name stamp middleware. Also quite strange, but it serves only one purpose. It add the current bus name to the new stamp to the envelope, and then just pass it iteration to the other middleware. Then we have rejectly derived message middleware, and it's strange to see that why it's in default configuration, because it's, as you can see in a PHP doc, this is only for MQP message brokers, and because we are integrating in with Redis, we can skip it in our configuration. But if you're using RMQ, I think you will need that. Then we have a dispatch after current bus middleware. It also serves only one purpose. It's middleware for adding specific logic after handling the messages. For example, if you process the message and you need to for example, clear cache or doctrine cache clear, something like that. If you don't have this this specific how should I say, behavior in your system, probably you won't need that, and it can easily be skipped from our configuration if you handle everything explicitly in your code. Then we also have interesting feature of this package. It's failed message processing middleware. If you configure it failed transport, then failed message can be sent to configured transport. For example, you probably had an idea if you processed the message in one message broker, and if it failed, you move it to the slower queue. For example, you use different message broker to just reprocess it again, to not waste your time for new messages. Middleware does one thing. It's check envelope for having specific stamp and add receiver stamp to it, just to reprocess it again. We have seen all not mandatory middlewares, and let's take a look on our mandatory middlewares. It's like for sender and start with sender. Here is the sender on the message broker on our diagram, and we have in send message middleware, we have a sender locator interface for getting senders, and event dispatcher to dispatch middleware related events and subscribe. In a first if statement, we check if the envelope has received stamp, and we need to skip this message from processing. Let's take a look in our sender locator interface. What it does? Sender locator interface just has only one method: make a map of senders to the message, and returns a list of sender interface for our message. Sender interface is also quite simple. It also contains only one method for sending message, and that's it. By default, we have sender locator, the class that implements sender locator interface. It has a map of message and class, and in the value in this map, it is our sender or transport. And we have a container interface just to get our senders from the for example, it can be DI or any container interface you have. If the message has a transport name stamp, we can get all the senders we need by this with this transport. Let's take a look on the send message middleware code. As we see in this code, it's quite simple. We get a list of the senders for our messages, and we have a dispatcher event that to send one event send message to transport event. If you wanna, you can just subscribe it somehow and do whatever you like with this event. In the sorry. In each of the members, we call send and send stop to add the send stop to a message, and just pass it to another to another middleware. And this is in the end of the code. What do you think can go wrong here? Yep. Yeah, you can easily lost your message here. If you haven't configured a sender and you haven't added specific parameter allow no senders, you just lose your message and that's it. And it's why it's a little bit different to configure it right. If we have no sender, we can just continue processing, that's it. And to understand how to integrate it, we need to see how it's done in Symfony. First of all, we're getting an event dispatcher from our service container and configure our sender locator in the send message middleware. We have our alias for our sender, and we have our message class as a key in the map. Now let's continue. If we are moving for the receiver part, first of all, we have a handler message middleware to handle our messages. We have also here handlers locator, like we had the sender locator, and here in the code we just from handler locator we're getting handlers for our messages. If checking if the message is already processed by the handler. In the handler locator interface, we have a little bit different picture. The definition is quite similar, but suddenly it returns handler descriptor instead of handler interface. Okay, what's inside the handler descriptor? It's a final class, and I don't like final classes because I cannot extend them, and also accept handler and options. And also there is an interesting feature because in most of the message processing libraries you can process only one message and one time. Is here you can process the batch of the messages at once. And let's continue with our handler middleware. Here we have two flows. As I said before, you can process a single message and the batch of the messages. We are getting handler here, our handler that will process our messages. And as you can see, there is two flows. It's a batch handler or a single message handler. For processing batch of messages, we need special object of that we will acknowledge all the message in multiple message at once. And for a single message processing, we just call function handler method, and that's it. And also we are adding stuff that we adding some specific stuff for the message to not process it again. To understand how to configure it in our application, we need to see how it's configured in Symfony. Also, we have a handler message middleware with our new handlers locator, and our handler for message processing also. And we're getting from and our message class as a key in this map. And looks like we are done, but we have a message bus with multiple middleware. But instead message middleware, the message processing stops, and handler not called in this case as we've seen before. So how does the handler receive the message? And as we mentioned before, you need to start worker. How to start in our documentation, you can see you can use messenger consume command as we've seen before. And let's take a look what's inside this command. Wow, it's just a description. This is just the description. It's a command with 300 plus lines, and this is just a description. For me, it looks scary. Isn't you? For you the same? In this command, we just need to only one small part of it, and this is the part we need this. This is our message bus with our configured handlers before. And we initiate object of worker with some options, and we start worker with these options. That's it. Inside the worker we have an array of receivers, but for some reason they call it here transport. Where the key is the transport name. Why is it transport? I don't know. We have we passed here our configured message bus. Also, we have event dispatcher. By default, it's null, but I suggest you not to do that because there is a lot of things you need to do in production with this event dispatcher. Also, we have array of rate limiters. For example, you have specific logic to, for example, for processing only 1,000 messages and then restart worker. For example, if you want to avoid memory leak or something like that. And also we have a receiver interface, and let's take a look what's inside. In a receiver interface, you have 3 methods. Yeah, and I think that's enough to work with our message processing. It's return first message. It's a get message, just a get. It returns array of envelope. As we know, envelope is consists our message and array of spans. Then we need one function to acknowledge that our message was already processed. If we have in some cases, we need just reject the message and do not process it again, and also function to reject our message. But why transport, not just receiver? But as you can see here in transport interface, it extends 2 interfaces. Sender interface we discussed already, and the receiver interface, we discussed it before. I don't know why they did it so complicated. I don't know, transport interface, I think there will be enough. But okay, this is their choice. As you can see, for example, in the Redis transport, it implements transport interface. It also has serializer inside of it. You can customize it. It accepts Redis connection and the serializer. And in a worker, everything is quite simple. You see an infinitive loop until worker should stop. And you getting a message from receiver. Then you apply rate limiting if needed for this transport. And then you just handle message. What's inside the message? Handle message. And here we have just checking if we need to handle this event. First of all, we also prepare array for making an acknowledgement after we process this message. And then we also call our bus, configured bus, but we calling it with specific stamps. For example, you see receiver stamps, consumed by worker stamps, and acknowledge stamp. Because in our sender middleware, we are checking if we have receiver stamp, we do not process it. But it also, after this middleware, it goes to the handler middleware. And probably we've seen enough to make our integration with our project, and let's try to do that. First of all, we are working in a Kubernetes environment, and we need somehow to stop our workers gracefully. For that, in these packages, we have a specific listener for that. Stop working on signal listener. Your signals can be configured here, and we configure just event dispatcher for our message bus with this specific event. Well, with message bus, with event dispatcher, that's all. Then we need to configure our message bus. As we discussed before, we have our DI. We add the message bus class. We first of all initiate our Symfony serializer. Then we configured our transport name for that. And then we configure Redis DSN to initiate now our Redis transport. Then we add to configure our sender map with the transport DI name. The transport DI name we use to get our transport from our DI container. Then we configure our sender locator. And then we configure send message middleware with the sender locator and our messenger event dispatcher. And as we see, we configured this part. And this part, we are finishing our configuration. As you can see, we are configuring test message handler. As handler, we added to the DI container. Then we adding some handlers, test message handler, and from DI we getting test message handler. Then we configure handle message middleware. And then we configure our middleware. For example, we adding all the mandatory middlewares, and I've also added ASBAT stamp middleware, just I wanted. And then return our message bus instance. We just configured this part, and then we need to configure our worker. To configure our worker, I decided not to do some much customization. I just wanted to make it clear and do with command that Symfony already provide for us. This is consume message command. It accepts routable message bus. It also accepts container interface, our DI container, and event dispatcher interface for a worker that we configured before, and also array of receivers, and result service listener and something like that, and rate limiter locator, for example, if you need a rate limiter. Routable message bus is nothing specific. It just accepts our DI container and fallback message. We need this routable message bus serves only one purpose. If you have different message buses in your application, it routes message in a specific message bus you configured for this message. And because I like Symfony, I also got the application from the Symfony app to configure this CLI application. As you can see, I configure our global DI, our Symfony app instance, and then bus from the last step, routable message bus, then messenger dispatcher, and probably that's it. We configured all the parts we need. This is probably all about the configuration. We did our integration with Redis, but you probably why Redis? Maybe you have some but about the Redis. Why it's not a good choice for the message processing? Yeah. Okay. It can lose your message if you just your server goes down. Yeah, and it definitely is. Integration with Redis is not stable. You can lose message if the server is down. For these purposes, Redis has approach with the Redis Sentinel configuration. And for our high availability, we need 3 Sentinel node minimum for that purposes. And we have it in production. And but yeah, if you look deeper into the Redis, into the Redis transport, you'll see that it has only one Redis Sentinel. You cannot configure multiple Redis Sentinels here. But it's look really strange. And we start to Google, and we see that's on GitHub there's a question about support for multiple Redis Sentinels, and you won't like the answer. Yes, current implementation doesn't supply multiple Sentinels node, and you have to manage them by yourself. Okay, like the one guy said, fine, I'll do it myself. As you can see, in the world, there are many smart people, a lot of smart people and kind people who did a different integration, and they are invented Redis. It's quite I would say it's quite old library, but it still has the feature that we need. For example, replication Sentinel, and we need to configure that. And I did some, how can I say? I did some open sourcing, and I've prepared the Redis transport as an extension for the message for the Symfony message bus. But I still don't have time to cover it with test. If you have a free time, you can help me and our open source community somehow. By default, Redis doesn't support stream separation like xgroup, xack, xclaim, and something like that. But it does support custom commands. As you can see, I've added some custom commands for that. And also configure a new client with these custom commands. And in standard Redis, standard Redis transport, you see this code. It's for getting messages from the group. In my implementation, it's look a little bit different, but it works. You can do it with your Sentinel configuration with multiple Sentinels node. And what we did today? First of all, we did a great job. We are here, and we dig deep inside in the messages and journals. We did this integration with no Symfony project, and we prepared integration with high availability based on Redis Sentinel. I think it's a great job. And let's some conclusion about the package. First of all, about the pros of this package. It's highly customizable package for async work, and a lot of possible options and for different configurations. Older features for the modern development come from the box. Support of any driver can be added without a problem. As you've seen, I've added Redis without a problem. And rich standard package for configuration, different serializer, different rate limiter, and other stuff. And some cons about this package also. It's too difficult to understand the right configuration and easy to make a mistake. Really easy to make a mistake. It's Really hard to integrate to project without a framework, but it's possible. Lots of configuration by default that makes hard to understand some part of this component. And all the routing of messages with the magic object envelopes and stamps, I kind of don't like it. And poor documentation of the Symfony website, I don't know why it's like that, because it's quite really good package and really used by a lot of people already. And no information about to configure this package without the framework, just nowhere. But now you have it. You can configure it in your project without a problem. And probably that's it, guys. This is useful link for you. Also subscribe for our PHP community. And if you have any question, just ask them. Thank you very much. Any questions? Что, я вижу тебя, что I see that you are wanted to ask question. Maybe, yeah. Sorry for my voice.
Did you try OS Elastic Cache with multi-easy?
OS Elastic Cache, well, we OS Q, first of all, we have in-house project without any for
Elastic Cache is Redis.
You mean Elastic Cache? What is this? No. Так, я не понял.
So, Elastic Cache has multi-easy, like everything is in AWS, and it's like highly available. You did some your own driver to support it, but maybe AWS natively does it already.
You mean the AWS? Something from AWS? You mean? No. We have we not hosted in the public clouds. First of all, we have our own cloud, and we have we didn't want to change our current implementation or current infrastructure, because we already, as I mentioned before, we already have spent a lot of money for our Redis clusters and our Redis Sentinels, and we need to somehow change it. And this is why, for example, we choose this library because it supports Redis streams, and Redis streams has a quite good guarantees like Kafka, and also have a modern things that kind of like consumer groups, streams, and other stuff. This is why we haven't changed our message broker. We decided to move to the Redis.
You mentioned earlier that using Redis, that there is a chance to lose your messages, right? Because I think they're kept in the memory.
Yep.
But I am aware that there's also the option that you can store and use the local storage, so the message can be stored there as well. So in case you have to restart, you can fetch them from the database. So your configurations understand don't use the local storage, just the memory.
Yeah, I do understand this concept. If you, for example, if you use cache, it can be you can do that because it's also this is mechanism copy on write in the Redis. But if you configure it, if for example every minute it slow down the whole idea of Redis, it's like will be nothing. You need to somehow to manage your high availability with different things like Redis Sentinel. You have to how can I say make one, for example, master replication for that, because in this case, if you want to store your information inside Redis, probably it will cause more problem if you do it very frequently. We have a lot of message to process, and even if we store it every minute, we will lose, for example, 10% of messages. In a payment system, you probably know what that means. It's a payments and something like that.
My question is, because due to this, let's say, latency that you observe with Redis, do you recommend Redis in general for pub/sub operations?
I'm not sure about the whole recommendation. I think that's Redis. In our system, we just had it like it was long ago. This project started with Redis. And then it was growing, and now it's hard to change it for any other implementation. We were thinking about Redis or RabbitMQ and other stuff, but the configuration, for example, the same amount guarantee, we didn't have this amount guarantee. Probably Kafka does, but for now Redis is enough. It's quite. We are satisfied with its speed for processing, first of all, and then now we have a guarantee for a message. Probably that's all we need for now. Probably will change, but we will see. Any others?
So you mentioned you don't want to change it because it's hard, but isn't Messenger offering this kind of abstraction where you are able to do this?
This is why this is one of the reasons why we want something like that. This has the interfaces and your kind of abstraction. But first of all, it's about the cost. For example, we have already big Redises in our infrastructure, and I think they cost enough. For example, first of all, and making this different setup, for example, with Kafka, it also might cause a lot of problem, and probably we don't. For now, we don't want them in production. Any others? Or we can drink a beer. Let's drink a beer, guys. Thank you.
So our speeches are finished. Thank you for coming, and join our Telegram and Discord groups. Now feel free to join us with more informal conversation, and of course, cheers for PHP.
Cheers!
And thank you, Alexander, for his speech.
Of course.